Mikula, sina meie uue JavaScripti spetsialist. Kas ma saaksin üks asja ka siia, kas asi on võimalik, et ma ei peaks käima menüüst ütlema zoom in'i? Kas seda saab JavaScriptiga juba kontrollida?
Millist zoom
näed, kui mul on siit on actual size on ju, slideshow'd ei taha selles režiimis teha. Nüüd ma hakkan siit tegema.
Oota, kui sa praegu muudad, ma arvan, et seda saab, see on ju...
Ta muudab teksti suurust.
Ei, aga siit sa muudad tegelikult jääs, tom muutub ka.
Ja tom muutubki on ju. Näed, ja nüüd ma teen nagu loengut on nagu selles zoom'i astmes siin. Kas ma saaksin see üles mingid nupud või mingi slaideri selle, kus seda nagu tõmmata? Ja no esimene küsimus on, et kas seda saab läbi JavaScripti üldse juhtida? Kui seda saab juhtida läbi JavaScripti, siis võib nagu mingisuguse UI nagu välja mõelda selle jaoks.
Tundub, tegelikult mida ta teeb, ta ütleb, et ta on vähem pihtu.
Jah, või ta muudab seda viewboard'i mingisugust seda korrekti zoom'i astet või mida iganes ta muudab. Et siis ma ei peaks siit menüüst nagu käima, et ma saaks...
Leht arvab praegu, et sa oled mingis väikeses täpet.
Jah, midagi niukast on jah. Et sest kõik ju jah. Leht saab, lehe sisemiselt muutuvad on ju, peaksid muutuma screen width ja height on ju. Või viewboard width ja height. Nii, hakkame lähemale. All right, so let's start. So you had some videos to watch. Hopefully everybody at least tried to watch them. Did you? Yes? Not yet? So then we do just a recap and try to actually use it. And now also the backend services or servers are running, so you actually can connect to the real SQL server if you didn't run it locally. So that was solved now. So let's start. So first, we now start to move over from the basics of like console writing or console code and like kind of like simple C# writing. We are starting now dig more into the depths of various libraries and actually writing some not necessarily more useful but abstracting away some low-level stuff into the libraries from the Microsoft, so we don't have to write our stuff so manually. So and the first complex thing we will use is an entity framework. So what the hell is it? And hopefully everybody already watched the lectures and you have already some kind of understanding what we are speaking about. So what the entity framework is an ORM, so object relational mapper. And the idea is, hopefully everybody is also in the database course. You should be, yes? Or at least you know what the hell is a database, more or less. So so the idea is, or the kind of the high-level concept is that we try to map something we have in the database, we try to map it into the objects. Or the other way around. What we have in the objects, we try to map into the databases. And initially, it started exactly from that side that we have the database, and whatever we have there in the database, we try to map it into the objects in our program. Now we work more the other way. We design and do everything in the objects, and database just magically happens behind the scenes. And we don't need to dig that much around how the database is actually constructed, what are the queries, what are executed there. Everything is abstracted away for us. So this is what the object relational mapper does. So we just deal with our .NET objects. So we write in C# our ships and whatever else, or persons and contacts and whatever we want to do. And not really magically, but at least automatically, the database with necessary tables, how to keep this data there, is constructed for us. And so the ORM, actually .NET has quite a few different ORM engines. The Entity Framework Core, or the Entity Framework, is the kind of, like, let's say, the official one from the Microsoft. So this is what we have out of the box. But there are some others also. So you can use Dapper is there, for example, NHibernate is there, and whatever else. So there's like definitely 10 plus of different frameworks on different complexity levels. Some of the ORMs are faster, definitely, than the Entity Framework is, but then they usually are much simpler. You have to write your queries manually and stuff like that. So mostly we will stick to the standards and deal with the Entity Framework. And behind the scenes, Entity Framework supports whatever you want to use, almost. So it supports different database engines. So we have Microsoft SQL. So this is kind of like obvious. Microsoft SQL has two different versions, actually three. So we have the ARM-based or ARM-based Microsoft SQL Server called Azure Edge something. This is what we discovered when we started to use those M1 laptops, that classical SQL will not run in the Docker anymore there, because it accesses disk in so low level way that it's not possible to emulate via the Rosetta. And then we discovered, or I discovered, that hey, there is an actually ARM capable SQL Server. Then there is a special version which is called the local DB, which is a one user SQL database running in process. So it runs with your code. Isn't exactly a server. So this works alone, but this works only on the Windows. There is no support for the local DB in any other platforms. So this is totally local. And then we have the full-blown Microsoft SQL Server. But all those variants do the basically Microsoft SQL syntax and have the Microsoft SQL support. They are just packaged differently. So this is what the Entity Framework supports the most. So this is the kind of like most widely supported. And if something changes in the Entity Framework or something changes in the Microsoft SQL, those always go in sync. So for example, if a new .NET version comes out, then there is automatically support for the Microsoft SQL Server and whatever like different variants of it. Then the next thing that Entity Framework supports is SQLite. This is also by the Microsoft. So if the new Entity Framework comes out, next one will come out in a few weeks. We have the new .NET release in the 9th of November, .NET 6, and Entity Framework Core 6 and whatever else it's called then. So the Microsoft SQL and SQLite will be there out of the box. So SQLite, maybe you already have some experience with that one. SQLite is just a file-based semi-actual SQL. So there is no SQL Server, and the SQL that SQLite supports is really kind of simple. The data types are really limited. Migrations are really limited, or there are no migrations. So if you want to change your database structure with the SQLite, it's easier to just delete everything and start from the scratch, and be happy with that one. So SQLite, for example, doesn't support dropping columns. So if you have your table and you already have some kind of column there, I don't know, first name, you cannot remove the first name column anymore. It's there, it's stuck. So the only way is that you will create a new table, copy the data over what you want, and then drop the old table and then rename the new table to the old table. Then you have like new structure. So it's not that easy. Entity Framework Core 6, the one that's coming out, tries to automate some of the stuff away. So it supports more operations on top of SQLite. A, because SQLite was improved a little bit, and B, some of the kind of like manual steps are now integrated into the Entity Framework. And then we have two other main database engines. So MariaDB. So this is the MySQL or MariaDB. That one is supported. There's a driver for that, but this is not from the Microsoft. And then we have semi-official, or let's say not driver from the Microsoft, but Postgres team is doing the Postgres integration pretty well. So the Postgres integration with the Entity Framework is working really, really well. So maybe the most popular, I don't know, is it the most popular, but kind of, let's say, widely used MySQL, this is the only one where the Entity Framework driver or provider is written by the third-party gang. It's called Pomelo something, 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 but it works really, really well. And the only thing what you need to do out of the box is you need to execute this command, .NET tool install global.NET df. So this will install the tooling to your .NET command line utilities, that when we need to create the database or migrate or drop it or whatever we want to do with the database, so then we have the commands for it. So those are not installed automatically when you install just the .NET. And then we have some nuget packages we need. So those we will add as we move along. Those are here just for the reference. And then we get to the main thing. And the main thing here is model. So everything starts from the code, and we don't think about the databases at all. So it's just the code, and no idea that there is a database. Okay, there is some idea here, because I did write here the complete kind of model. Can be actually simplified, but in theory there is nothing immediately visible that we speak about the database here, or it will be, the data will be stored in the database. So you start with just writing your POCOs, or in the Java it's called POJOs. So plain old Java objects or plain old C objects. So here are those POCOs. So we just describe what our business is about, the same as we did in our Battlefield program, Battleships program. So we describe what our data is doing. Here the example is about our kind of like classical contact database. I have been writing that one at least 100 times now already over the years. And I always kind of like improve it a little bit every year. So now we have the new approach that the thing that was called typically a person is now an entry. So it's more understandable what it is. So idea here is that we try to write a phone book. So your application keeps track of contacts, basically. So we have like list of friends, so called entries, or you can call them persons if you want to. Every entry in our phone book has a first name and a last name. So kind of like obvious, yeah? And then every entry in our system here that the model is describing has a list of contacts. So there's this collection of contacts. So what is a contact? And why this thing here is an ICollection and not a list? You can actually use a list here if you want to. Doesn't change anything. It is actually initialized as list anyhow. Problem here is that if this thing goes to the database, so it maps one-to-one against the database, then you cannot write something like this, like let's say it's entry.contacts and take the 5th element from the list. List allows you to do an index-based access, but how will you map this against the database? So which is the 5th record in the database? Based on what? On what order? On the date, on the first name, last name, primary key. So it's unclear what the 5th means in this context. So if it is a list in the memory, then it's absolutely clear. We have the list in the memory, every item is already fixed in the memory, and we can say that, yeah, this is the 5th element and access it. But how is the list in memory mapped against the list in the database? Absolutely no idea. So it's not so clear immediately. And that's why we don't use the list there, but we use this ICollection. So this is basically a simplified list. And the only thing that it removes from the list is this. You cannot access via the index anymore. So it's not allowed, because the index access is not defined in this interface. So it makes it a little bit more realistic. Although you can write a list here, happily Entity Framework doesn't complain, everything works. But if you try to access it via the index, something like unspecified things will happen. It's not clear what will work and what will not. So better do not allow index-based access. So we have the entry, and it has a list of contacts. Then we have the contact. So every person or every entry has a bunch of contacts. And contact basically has only one thing, which is the contact value. So there's only one thing that the contact actually holds or keeps track of as a data, is this. Plus, the contact will point back to the entry itself, so to whom this thing belongs. So actually, I want to make it a little bit more simple for you. What the hell is this? Let me make a new one. Oh no, we have the demo somewhere. No. Okay, here. Actually, still, I make a new solution. Let me start from the scratch. Here. ja see mingi Java paneb nagu edasi-tagasi. Joonistab, siis joonistab üle ja kuna mingisugune uimerdab, siis on näha nagu vrr.
Ta tõi nagu näitab, et see kiti.
Ja, just. Night Raider paneb. So, all right. So, I started with the empty solution. And I can start to design my stuff. So the first thing that we spoke about, that we start with our models. So the plain old classes. So let's add a project here. No, not here. A new project. And typically this is called domain. So what is our application about? And it's a class library. So what will be model? Give me any ideas. You all have you have your database courses. Let's model something. Let's do something different than that's what's on the slides. You're all students. Okay, let's do simplified ease, yeah? Student information system, like really simple one. Mikker on sees, punane raam on ümber, kõik on. So let's start to think first. What the hell is it? So what's the central thing? Student.
Courses.
Okay, let's say student. We have a student. We have the course. What else we have?
Grades.
We have the grades.
Teachers.
Teacher.
Programs. Like cybersecurity or
let's try to keep it as simple as possible. Let's say it's a middle school or something like that. So we have a course or subject. We have the students in this specific course. We have the teacher. Maybe this and this is a single entity. Maybe this one is just some kind of like person. If we do it, let's try to do it really simple. We have a course, we have grades, we have a person, and maybe a homework. Nice. Okay, something like this. So those kind of like main concepts we need to deal with. So let's say this is a student / teacher. A course, a grades, and somehow we have the homework there. Black will be better. Okay, that one draws. So let's start from somewhere. So first we have the course. Okay, course probably has the name. And this is it, I think, yeah? We don't hear about the class or year or whatever else, semesters, so just course, like mathematics, and this is it. Okay, then we have somewhere, we have the, let's call it, I don't know, person. This one has the first name, has the last name. Then
number.
First name, last name, easy enough. No more data. Then we need to think, how is the course and person connected with each other?
Many to many.
Is it many to many? Is it one to many?
It's many to many. Because one course can have multiple students and one student can have
Multiple courses. Okay. So this already means that this thing gets now a little bit more complex. We have the in between. We have the course person. Yeah? Which means that there is a course, there's a person, and then there is probably a role, some kind of, like, let's say, is student, just in case. So we can say that somebody is a teacher in that course. Okay, so this means that course can have many persons, yeah? So let's draw a connection here. Like this. Everybody knows those symbols. Yes? Who doesn't know?
Not exactly.
Not exactly. So let's go over those, because we actually need to draw those a lot, or you will need to draw those a lot in your real life. So this is clear. We have this kind of connection between the course and the course person. Now we need to define what this connection, how this connection should look like. The idea, the main concept is this. You start from the course, and you go by this line, and the description, what the course has, what kind of relationship the course has with course person, is described at the end of the line away from the course. So first you kind of like, you look in this direction, yeah? And now we have three options that you can describe. And the options are 0, so 0, 1, and then we have whichever here, let's say many. Or let's say it's not possible to draw here, let's say, let's put an n here, many. So this is the Z. So you either have a 0 of something, you have 1, or you have many of something, or and end. And now we try to combine those things. So the first thing is, when the course is created, can we have course without any students? Yes. Is it possible? You asked that, you don't know exactly. So describe me. Is it possible to create a course and we don't have any students? Yes or no? What do you think?
Yes.
Definitely, yes. So you write the 0 here. Is it possible to make a course and the course has just one student?
Yes.
Yes. Can we have many students in the course?
Yes.
So now we put this, it looks like this. I don't know how to draw it here. You can draw it like, let's say like this, yeah? So this describes the many end. So we have course can either have a 0 or 1 or many students. And typically when you speak about the databases, the 0, 1 and many, all those options are anyhow included in the many. So we don't draw those 0s and 1s. Only in some really, really special like business cases when you want to be absolutely sure. For example, you can do something like this and say that there cannot be a course. What does it mean? When course is there, there has to be at least one student. But this is not enforceable by the database. You have to do it in the code. So this is not the database specific. You cannot implement it in database. Okay, you can write some kind of weird stored procedures for it or something, but like in normal database, you cannot enforce it that it is like has to be a 1 there. It's not possible. So typically we write just like this, a many. As soon as you do this, if you finish one end of this arrow, you need to think, or you will always finish what it looks from the other side. So when we speak about course persons, this one here, how many courses will this have?
Many.
Think about it. Istusid esimesse ritta, nüüd saad. Aga õpid kõige rohkem. So course and course person, yeah? We know that every course has many connections from here, yeah? Course persons. What about from this side to here? From course person, what's the other end of this connection? How many courses are there possible? Can we have course person without the course? Is it possible? No? So 0 is off. Is there one course?
Yes.
Yes? Is there many?
No, because then that would be a different course person.
Absolutely. So there's only one. So there cannot be, in this side cannot be, because even more, is it possible in the database world, you are in the database course, is it possible to have many-to-many connection? No. So if you have many on this end, it's physically impossible to have many on this end. It's not allowed in the databases. There's no such thing. If you do this many-to-many, we actually did here many-to-many, virtually in our head. This means that there has to be this in-between table. So in reality, there cannot be, on this side, there cannot be a many anymore. So if this end is many, we know that one is true, then this one cannot be. And 0, there is no point on it. So there's not possible that we have the declaration that somebody has declared that student A will take the course B, and there's actually like no course B existing. So this is not possible. So it's this way. What about this connection here?
The same.
Can person have many courses? Yes. And of course you can do those if you want to here, but basically we don't draw those, just out of convenience. Does course have one person, or many, or zero? Just one, and it's always there. So if you have the declaration with the course and person name, this means that the course has to exist and the person has to exist. So you have those. Okay, now what happens next? We have the student teacher covered, we have the course covered, we got the course person, now we have the homework, yeah? Homework as what? Description. Probably this one has some kind of like, let's say, a grade. So homework as description. Where is this homework connected to? With course, yeah? So every course has many homeworks, probably. Not just one, but many homeworks, yeah? So this means that we have here a many on this side and one on this side, because there cannot be a homework without the course. There cannot be just like homework floating around, not attached to anything. Like you did discover random homework on the corridor somewhere. Side quest, exactly, but not connected to anything, just random thing. So homework has a description. Okay, what you need to do, maybe there's like deadlines and whatever else, like bunch of data, but description for us is kind of like describes what the homework is about. Okay, and now happens what next? When I give you the homework, so the homework, I as a teacher give you the homework, this is attached to the course. And now I need to start to grade those homeworks, yeah? Everybody will start to present the homework. Where will the grades go? So this here is the overall grade, yeah? What you will get at the end of the semester. So you are graded. But where are the, but this is average of homework grades, yeah? So where are those homework grades?
Between homeworks and person, maybe.
Sure? You think? Because here can be a person who is not taking this course.
Maybe a list of grades for the person.
Is it list of grades for the person, or is it list of grades between the homework and course person? Probably.
Yes.
Because those grades will be connected with this specific course which you are taking. So first you have to declare that you are taking C# programming, and then the C# is here, C# will give the homework, and now when I start to grades, so a grade has one homework. This homework will have many grades, and this grade needs a person to whom this grade belongs, and this belongs to somebody who is actually taking this course from here. So there's one on this side, and everybody here can have many grades. And probably this one only has some kind of like value and maybe comments and whatever else, feedback. So is this our kind of like simple UI system? So this is what you have to do every day for the rest of your life. Every day I'm shuffling. So this is what I'm drawing every day, basically. Night in and night out, from morning to evening. So we got this, how many entities then? 1, 2, 3, 4, 5 entities, yeah? All right, so let's do it. Let's start to describe what is what. So the first order of things is that we describe everything in low level, in like, we don't think at the database first at all. We do it as simple as possible, just like basics. So first we have this person. Person has few properties, like first name, and then probably last name. And this is it.
ID?
No, don't want to. First, we don't think about the database or anything like primary keys, foreign keys, whatever else, not there. So then the person is clear. Then we have the course, yeah? So let's add the course. Course name. This is my kind of like preference or like experience. Don't use simple words like, for example, name, value, stuff like that, event, entity, or whatever else. So this will conflict somewhere in the framework finally. And the name is especially troublesome, or value, because we will have something like this. A.name equals B.name. What is A, what is B? Is A course and B is a person? Like what I'm doing here? So what I'm comparing with what? So much simpler is this to read later. And if you see something like this, then it's obviously clear that what the hell I'm doing here. Why I'm comparing a course name to the first name. But if you keep everything like name everywhere, then it's like, what the hell is it? Like, because you have like in those lambda syntax, in this delegate somewhere, you have like A, B, C, D variables, like, and then it's like really hard to understand what the hell I'm speaking about anymore. So don't use, or at least I recommend that don't use those overly simplified short words. So like name, value, and stuff like that. So it's a course name. So then we have the next simple thing we see in the list is this homework, yeah? And probably also homework description, not just description. Okay, now the simple things are kind of over, and now we need to do those many-to-many relationship tables. So we have the course and the person. Course, person. And course person has only two properties, eStudent and grade, yeah? So this is the boolean eStudent. Or you can do enum or whatever else if you want to. So depending how many options there are. And maybe it's an grade is integer, I think, yeah? Probably should be full number. I think database doesn't even have the unsigned, so it's just an integer. Okay, we have the course person, and initially we don't do anything with those arrows and the relationship between those. And finally we have the grade, and there can be named like homework course person connection, but we have special name for the connection between the homework and the course person. It's called the grade. So maybe in the course person we can call it the final grade, more understandable. And here it's property int grade. Can't be this, so it's let's say grade value. And now we have like all the basics is there. But now we need to describe those relationships. So because currently we don't have any connections between those entities. That's only in our head. So let's start from the top. Every person can have many of those course persons. Can we have better name for it? What's the course person? Is it kind of like declaration or no? What do you do in university with the red?
Person
Course. Submitted
like
courses.
inside.
In Estonia, it's a declaration. Yeah, every semester you make a new declaration. What will you study this semester? Yeah,
Yeah.
we have the red line date somewhere. You have to finish your stuff. What's it in English?
Study plan.
Study plan.
Team.
But okay, study plan is the overall. But if you have the one line in the study plan, what do you call it in the study? One line in the study plan.
Admission.
So yeah, admission, submission.
I think declaration is best.
Yeah.
Declaration is best. Okay, so we can rename it. That's the declaration. So then it's the declaration. Let's be even more clear. It's a course declaration. Let's say like this. So now we can say that every person, let's start with the list, has this course declaration, course declarations. So every person has a bunch of declarations, and we don't think about semester here, so it's just overall. Okay, and as soon as you describe the one end of it, the one side of the relationship, always go and declare the other side also. So looking from the course declaration, it has one person, yeah? So this means that there is a person. Okay, so now we are inside the course declaration. This one has one course. So there is course here. So now when we did the course, from the course, we need to do the other end. From the course, it has many declarations. So this is the list of course declarations. Okay, from the course we have many homeworks. Now we do the other side. So what is it from the side of the homeworks? This has one course. Okay. And now from the homeworks we have many grades. All right. So now we are on the grade. From the grade side we have one homework. And when we are in the grades, we have what? One course person, one declaration to whom this grade belongs. Okay, and now from the course declaration, we have already the course is there, the person is there, so just the grade is here. So one declaration, course person, or the declaration can have many grades. So all the homeworks that you have done. So this is once again the list, course declaration, course declarations. Now I'm done. This is probably one of the most complex things in programming. Is the database or the entity design. What the hell is your business about? If you make a mistake here, and it's hard to make a mistake here, I mean technical mistakes are not happening here. Here you are making design mistakes, and if you make a design mistake here, then your whole code and all you're doing is wrong. And it's really, really hard to fix later on. So it's mistakes here in the underlying data structure are really, really expensive. So carefully think and make such drawings and think through what the hell are you speaking about, what shall happen. It's not, and it takes probably years and years of practice to do it well. So database design, at least as long as we speak about kind of like business application programming, is probably the most critical step you need to do. And mistakes and redesigns are expensive here, because if you change anything here in the data structure, then you have to redesign your whole application typically. So then all your views, stuff, your UI, everything is wrong. So careful and think things through. How will this stuff work? I think in my, let's say, typical application, 40 plus tables typically, 40, 50 plus. So this gets complicated. I can show you one drawing, for example. Let's see, can I find it? You will start to draw something like this up. Here you have all kinds of like fancy features, like it's connected to itself. Like a menu system, like menu and submenu and submenu and submenu. All kinds of like those kinds of drawings. And this is fairly simple yet. Not that complex. But to think it through, for example, to come up with this drawing here, it has taken me, I think, about 5 years and 3 iterations. So I have written the same application again and again and again and redesigned it. And I'm still not happy with that one. We discovered extra problem a few days ago, and I have no ideas how to fit it here. So I have to go back to the drawing board and think again. So it can be complicated. So all right, and now we have basically everything we need to have. And actually, this thing will almost work. The only kind of hard limitation that the entity framework and the database has for you is that every table in the entity, almost every table, it's not hardware actually, but every table needs a primary key. So how can we detect if we have the entity or if we have something in memory, how can I point out where is this thing in the database? So if you have this, let's start with the person. If you have the person in the memory, this object, how can I find it in the database? Because entity framework will map between the objects in memory and in the database and tries to save those and create those and retrieve those. So it has to know that this object in the memory is in database somewhere. Where? What is the connection between the object in memory and the thing in database, the row in the database table?
ID.
Some kind of ID, yes. And in the database world, it's called a primary key. So there has to be just one specific way how do we identify this record. So for example, we can do something like this and say that for us, the first name is the primary key. So there can only be one, whatever, Sasha, and this is it. Would work technically, so totally doable. Or we can make a combination out of the first name and last name and say that the first name plus last name has to be a unique combination. Will this be okay?
No.
In real world, probably no. Because we have first names and last names are heavily overloaded, yeah? We have the same persons, or different persons with the same family name and first name. Can we use, for example, social security code?
Then it will only work for Estonians.
No, let's stick to the Estonians. Can we use Estonian social security code?
Yes.
You are too optimistic. Actually, no. Freaking hell, we have conflicts in Estonia. We have different people who have the same social security code.
Really?
Yes, has happened. For whatever reason, however it was given out, I think it was fixed now, or a few years ago already, but let's say 10 years ago, we had different persons, physical persons with the same social security code. Yeah, kind of like, because the social security code was given out initially on the paper, so different offices gave out the same social security code somehow. So it was like huge problem for persons. So it's kind of like should be okay, but not really in Estonia. Okay, mostly okay, and nowadays probably is okay, but it's still kind of like doubtful. Then we can think out if it's some kind of like user system that you try to actually we need to, the person will log in, like this uni ID, for example. Like this will be definitely like unique, yeah? Or we can say that email address is this unique thingy. So we can figure out like something. The simplest thing we can figure out is this, that let's give it a random number. So let's give it a random number, and let's make it work like this, that the database will automatically generate those random numbers and will assign those. And since we have this one thing that should be automatically created, and this is the duty of the database to take care of it, so this concept is called a primary key. And if we want database to let it create and automatically assign values to it, then we typically stick to the numbers. And since random is maybe not so good because random is hard to organize correctly or sort or do stuff like that, then let's do it in the sequence. So then it just starts with the number 1, and every new record will get the last one plus 1. So it just increments and increments and increments and increments. So we need some kind of primary key here. How to identify it from the database to the thing in memory. So if it's a number, then it's an integer, kind of the simplest thing that the database does. And now is the question, what's the name for it? And we have different options here. In IT or in the programming, we can take 2 approaches in everything. And those approaches are described convention over the configuration, or the other way, configuration over the convention. So basically what it means is this: can something happen automatically, like the default values are good enough, so then it's the convention over the configuration. So stick to the standards and it just works. And the other way is kind of like you have to configure everything always manually. So here we try to stick to the system that convention over the configuration. We don't want to go and say specifically that this thing here has to be a primary key. So then the simplest thing is you can just call it an ID. And if the thing is called ID, then Entity Framework can pick it up and discover automatically that if this thing is ID, then it will be made or used as a primary key. So we can say that this is primary key in EF by convention. If you want to do something, don't write it like this. String social ID. So that one, Entity Framework will not discover as a primary key automatically. It's just weird string here. What the hell is it? No idea. And now you have to configure it. Then you can theoretically say something like this, a key here on top of it, that I want to make this email or whatever it is as a primary key here. So, but let's try to stick to the convention. And the convention actually has 2 shapes. The other one is this person ID. So you can use either just ID or class name plus ID. So whichever takes your fancy. Maybe initially this class name plus ID is kind of like more understandable, that this will be a primary key. What do you do in your database course? How do you call your primary keys?
It is just a primary key, just ID.
Just ID? You don't give it any specific like table name plus ID or like person ID, grade ID, whatever else?
We actually do, yeah. It's
Person underscore ID. So we can initially stick to that one. Actually, in the long run, it's easier or better to use just an ID. Then it's easier to figure it out via the reflection and do some like automagical tricks with entities. So then the ID is a little bit better, but initially it's kind of like more understandable if it's called class name ID. So this means that since every entity here is in the database, we need the primary key everywhere. So let's start from the top. Course prop int course ID. Course declaration. And person already has the ID. Now the next thing we need to think about is this. That, let's start from the top. With the person, everything is clear. So our database table will have those three columns: person ID, first name, and last name. So we have three entries in the table. What about this? Where is this course declaration kept?
Foreign key.
Foreign key, some kind of, but where? Person table definitely cannot have because there's a list of courses you take here. There has to be like many foreign keys. Like with your name, first name, last name, you have like 10 declarations. Yeah? You have 10 different subjects you're taking. So where is this course declaration actually kept? Where is this key? Some kind of foreign key, definitely. But where? You're taking the database course. Hey, guys. What? So let's say, I will clean this one out. Everybody remembers what was here. So let's draw the tables. So we have the person. So it has the ID. I will just write ID here. First name, last name. Yeah? We have kind of like table like this, yes. Then we have the somewhere is the course. This one has the ID and the name, the physical structure. Yeah? Yeah. And then we have the declaration in between. So this one has the ID. Then it had what is teacher maybe, or something like this. And now we need to figure out this. Every person has many declarations. Declaration has one person. Every declaration has one course. Every course has many declarations. We have those relationships. So how are those relationships actually described physically in the database tables?
Declaration has person ID and course ID.
Yes. So the foreign keys are here. So here we have the foreign keys that point to the person and that point to the course. So here we have this person ID and somewhere we have the course ID. So inside the declaration. So this means that when we have the data, let's say 1 and math, and 1 and I don't know, Kalle Tamm. So what's the declaration looks like? 1 is teacher, 0, no, person ID, 1, course ID, 1. So this is what our declaration would actually look in the database. So this is the ID, 1, 2, 3, 4, those go in a row. So this is the value for the boolean, is teacher, 0 is false. 1 points to the this ID, and this one points to the this ID. And this now has, like, let's say we have here the second person. I don't know, let's say Yuri Tam. So he's not teacher. Now this one was the person ID, so here would be 2, but he also takes the math, 1. And now we get this one-to-many. So if you look from this side, this ID, can we have many here, or is there many? Yes, there actually is. We have already 2 here. But from looking from this side, row by row, just 1. So this only points to the one specific record here. This one points to the also one specific record here. So this is how the one-to-many is physically in the database. Okay, so what does it mean here in the C# context? So this list here is purely imaginary. So in reality, there is no list. So this is just constructed in memory after looking at the course declaration table and discovering the foreign keys from there and count those. So but let's look at the course declaration. And we have here this person. Yes, in the course table, we have the person ID. If we have the person ID, then we can also find out the person from the ID. Now the question is that in the table itself, we cannot have a person. So physically, there cannot be a table inside the other table, so it's not possible. So there has to be just a foreign key for it. Now with the foreign keys, what can happen here is this, that either you will write your own foreign keys, or you let the entity framework to create those. 2 options. And it's better for your code to actually write your own foreign keys. Do not let entity framework create those foreign keys for you automatically. Although it will work just fine, because entity framework will see that, hey, this course declaration, when it is in the database, it needs to reference the person. Since there cannot be a table inside the table, so automatically it will add the person table and make a one-to-many connection, and will create the person ID for you. So don't let it do automatically. And by convention, so this is the foreign key, make it visible. Use naming convention. And the same here, course is also integer, and it's the course ID. And this one was the primary key. So this goes everywhere. So the course, this has 2 lists, nothing to do here. Course declaration, foreign keys are declared. Grade has also 2 direct relationships. So it's an integer homework ID, long name. No, it's an integer course declaration ID. So here the course needs a foreign key. And person just has a list. So now I have all my foreign keys described, my primary keys described, and my connections between the entities. And here, if you do this foreign key, it will only work as a foreign key if you have the relationships also here. So if you have this one-to-many relationship one side, this one will only work as a foreign key if there's actually is a relationship. If you comment this out like this, then it's just a field just a property in the table. Doesn't have any special meaning anymore. But if the entity framework will discover that, hey, there is actually this homework and there is a property called homework ID, then it is automatically declared as a foreign key, indexes are made, and all those stuff that the foreign keys needs. So the names have to match here. Or then you are back to this, that configuration over the convention. You can definitely use whatever names you want to, but then you have to point out to the entity framework that, hey, this weird field here, this is actually foreign key or primary key, whichever you're doing. So you can do everything manually, but it's kind of like, don't do it. Bad approach. But it is doable. So this describes how the database, or not database yet, but how the entities will look like, and with just an addition, we need to identify everything against the database, so we need those foreign keys and primary keys. So we declare those. And we can actually skip the foreign keys, will work just fine initially, but it's kind of hard to program, especially in the web context, that you need to access those keys in the URLs somewhere in the forms. So we need to see what the value for the some kind of foreign key is. So this is it. Now we have our kind of database, not yet database, but our entities are ready to be added to the database, and let the system create the database for us. So let's take a break. I know, 15 minutes at least. So let's take a 20. Let's be back at 45. And then let's actually make a database out of it.
Я ICollection не знаю. Ну да. Ну, типа, вот сейчас заклеил курс, и он за домашние оценки получил. И эти оценки, типа, там сохранились. Ну, я из того, что первый раз делал DbDemo, вот со стороны так хорошо видно, слава богу. Я просто половину получу.
Ну, да, я
думаю. Самое сложное это первое начало состояния. Ты можешь попробовать. Дальше
Ну, ему сразу же вечеринки запрещены и отказали. Зачем? Зачем?
Может, дофига народу, очень экстремально. А вы скрываете?
Еще раз. Если будет, я сейчас не буду. Там главное вообще будет, ты посмотри, как она выглядит, сколько здесь места, чем началась, чем
Так вы типа знаете, пускай он же вас всех не знает.
мы хотели с его аккаунта, а уже все, не было текста.
В смысле, он все нельзя.
Нет, там этот кран, там видно, вроде там есть, он хотел сохранить, потом через какое-то время написал, мы попробовали, уже все сделали.
Tõuksiga aga tõuksiga on vaata paha tagasi tulles kuradi kohv käes. Nii. All right. So far, is everybody happy? almost. I mean, with the theory. Did you understand what I was speaking about? Yes. So you know how to draw up the relationship, you know how you draw your entities on the board or on the paper, what is one-to-many relationship. Somewhere we will discuss what is one-to-one or what to do with that one. But definitely like 95% of the, or even more, of your relationships are one-to-many. So we have covered those. Okay, so let's go back to the theory a little bit. So now you understand everything that is here on the slides or on the whatever documentation I've made. And then we get to the next part, which is we actually need to tell the entity framework that, hey, or we need to tell at first to our application that, hey, we need the entity framework. And then we need to tell to the entity framework that please make a database out of it. Plus we need to tell to the entity framework that what kind of database engine to use actually and where this database engine is located. How to contact that, how to contact the database engine. So for that, what is the kind of the base class of entity framework is this one here, the DbContext. The DbContext describes what the database will be and where it is and how to connect it to it and what tables are there. So everything kind of like the central point is the DbContext. So let's add that one. And typically this is new project, class library, and this is called a DAL, data access layer. So everything connected with the database, with how the data is stored, whatever is the method for it. Typically this goes into some kind of data access layer type of project. Application DbContext, and we want to derive from the DbContext. Of course, there is no such thing as DbContext out of the box. Find this type on NuGet. Microsoft Entity Framework Core. Now pay attention. Do not use anything that is just entity framework. The just entity framework without the word core on it is the old entity framework, and that one works only on Windows. And this has not been developed now for at least, I don't know, 5 or 6 years anymore. So don't touch that one. It just will get bug updates. Although it is really, really feature complete, it's much, much bigger than the entity framework core in some senses, but don't go there. So we need this Microsoft Entity Framework Core. And let's install that one. So now I can have a usage for it. So now I have my DbContext. And the first thing, plus I need to rename the class file. I have my kind of like abstract database. It isn't connected yet to anywhere. It's just a kind of like in memory. But the first thing I want to describe is what are my database tables, what entities my database needs to track of. So property, and this is called DbSet. And the easiest way is to just go down by the alphabet, so the course, and it offered me right name, courses. And I need the reference and import, so I can actually see the domain project from here. Actually, this will be enough. Just referencing one entity is almost enough in theory. In practice, no. In theory, the entity framework will now go, when we initialize it actually finally, we'll go to the course. From the course, it will discover that, hey, there's actually also course declarations and homework. Then it will go to the course declaration. From course declaration, it will discover the next things, next things, next things. Finally, it has discovered everything. that has some kind of connection between the items. And if those things are connected, then the entity framework will see that, okay, if you want to save the course, then you need the rest of the stuff also, and it will create all the tables for you. The only problem is the same as with the foreign keys, you cannot access them really well. You can only access them through the course itself. So you need to create a course object and then the list inside the course, and etc., etc. So you cannot make any kind of like direct queries against the database that what is there in the persons. So list everything. So everything, all the tables or all the entities that I know that will be there in the database are also listed as a DbSets. The ordering is not important here, at least for me. After many years of kind of doing this, I tried to keep those in the alphabetical order. Then I can verify against the domain project that everything is there. Initially, kind of like my first approach was that like in the order of like importance, that person, and then from the person this and that and that. And then I finally somehow will forget something. So it's easier for me at least to do them alphabetically. Because there is like, if there's 40 of those, then it's like quite a long list already. Okay, so meanwhile, let's add also nullables here. So the nullable reference types. So we had it somewhere in the documentation. Because entity framework also actually supports those. So it has to be called this, Directory.Build.Props. New solution folder, solution items, yep, items. And let's add those. So, can I load those again now? Reload project. Why? Mono runtime. What? Load file. What are you speaking about? How can the load fail? Comma separated list of warnings, yes. That's
sul on see nullable taga mingi imelik karakter.
oot.
Kus sa kopisid?
Kusjuures siit. Vaata üle, mis siin on jäänud sisse see mingi. Okay, can I do it again? Yep, now it works. But is it really working? Okay, I got the errors in the compilation phase. Is everything okay here? Why isn't my warnings as errors working? comma separated list of warning numbers to treat as an errors. Yes. So. But it should actually do something. That should have an error here. Kuulge. Let me close everything.
kusjuures failis ei ole seda. Kiitis on fail korras.
Ega see on non-printable, non-visible. Sa vajuta ükskord backspace'i ja...
See ei ole nii.
Vajuta, kus ma sain selle saada.
Ma arvan, et see on mingi MP-doksi pildi käigus midagi juhtus ka. Nüüd pärast proovi.
But this should be an error. Where is the error? Why isn't this thing working? Yep, it's in the correct place. In the solution folder, it is. What the hell is it doing? Do I need to invalidate something? Some kind of invalidate caches? Yes, please. Invalidate and restart. No, now I got it. So I had to do this. File, invalidate caches. So now I have all those nice fancy errors. And I can do also rebuild solution and then get those all here. So let's fix those one by one. So course name must contain a non-nullable value. So I can just say that default, don't worry. Declarations, default. Homeworks, default. Person, first name, default. Last name, default. That one also default. Actually, let's see those all. That one is okay. Here, default, default, grade, default, default, homework. That string is a default. And the same thing with all the DbContexts, with all the DbSets. So basically everything is just default exclamation point. Ой! Выtam, посмотрите туда. Этот вызывается Павел, наш ассистент. От Америки, прямо. Русскоязычный. Если у вас есть проблемы, тогда он с вами занимается. С правильным, õigete sõnadega nii-öelda, с правильным терминами. сюда, туда, на, по. Все вещи будет.
А где же контакт?
Вот, контакт здесь. Где мой контакт? Вот. Видишь, контакт есть. Есть. Как мы без контакта? Единственный прогресс не person, а entry. Да-да, потому что person уже как-то непонятно какой person. Это person или этот identity person. Теперь entry, да.
Kui mitu kontaktpunkte seal juba oled teinud?
Kes seda teab, noh? Ma arvan, mingi 100 umbes.
Mitte ükski ei ole nii.
Ükski ei ole nagu, ei ole nagu nii hea kui võiks. Okay, so let's get back here. My only thing or notice about those nullable reference type is this, that please think what you are doing. Is the default exclamation point okay here? Or is it not? Or maybe it should be actually something like this. Maybe it should be empty list. Or maybe it should be actually nullable. Maybe it should be this. So you need to think about it, because there are implications, actually, and long-term implications. What will happen with those different choices? So there are no kind of like correct answers here. This depends how do you want to design your code and what approaches do you want to take. But at least think about it, which is correct for you in this situation. So actually, what I will do, you can either start with this or all those reference things I will actually set as a nullable and say that they actually can be a null, because those are dependent of some kind of database join. And if I don't do the database join, then they will be nulls in memory. So I better declare those as nullable types. And this one also here is a nullable. So all the lists and all the references. So did I get them all? Yes. Strings are okay. So here also, this one is a nullable and this one is a nullable. And here the default is totally okay, because entity framework will actually initialize those properties for us. So for us in the code, they will always have the value. I don't need to check that those are null or not. I know that they will always have a value and there's no issue about it. All right, so now we have our DbContext. So the next problem is that where will this DbContext actually connect to? So there is no database engine, there is no connection string yet here. It has to go somewhere. So what to use? So here we have different ways how to approach it. And let's first take this approach here. Do not hard code database configuration. Let's hard code it. So we have this onConfiguring method. We can override it. It's theoretically okay inside in case of console applications and initially. And we need to use some kind of database engine now. So where will it actually connect? So use UseSqlServer. So this is the Microsoft SQL Server. We don't have it yet. So let's see, do we even have anything out of the box? Use
Nothing.
memory cache maybe will work. And this is it. Or even that one is doubtful. So we need some kind of database engine to be installed. Basically, you have two options. okay, you can use whatever, but out of the box initially maybe this SQLite will be okay initially. It's file-based local and this is it. If you plan to have like any longer career in software development, then probably you can skip the local DB and start with the full-blown SQL Server. That one you can either run locally in your own machine if you want to. I do recommend Docker for it, and then you can connect to your Docker instance, or you can use the server that I'm providing to you. So we have SqlServer up here running in the school now. So let's, I can use that one. So the first thing I need the package for it, that actually this UseSqlServer can work. So manage nuget packages, and I can just search for the SQL Server. Once again, pay attention that you don't install framework core.SqlServer, but entity framework core, not just entity framework. So I need that one. So now the UseSqlServer is okay. And now it just has one parameter, which is the connection string. So this is the connection string for the local DB. So this local DB will work only in your local Windows computer. So this is this one user only on Win. There is no implementation of it in other platforms. So we need some kind of the other connection string that will actually connect us to the full-blown SQL Server. And I also have it somewhere here, hopefully at the end. Yes, here. Let's grab the full thing. So this is your connection string. You can grab it from the slides or from the materials at the end. And there is one important notice here. So you share one username and password, student and student pass1. So please replace this thing here with your UniID. So otherwise you will destroy each other databases or do whatever else. So basically everybody can see each other databases. One more notice. This server here is purely for our own usage during the teaching. Please don't connect your commercial databases against it. Has happened. It was publicly accessible previously, and students happily started to use it for commercial purposes or whatever else. And then during the summer somewhere I closed it down, and then went few hours, and then I started to get complaints. Hey, where did our database server go? Like, what? What are you doing there? School is over. Go home, go away.
Is this the UniID with like the email address, like at TTL?
Basically, do this. Do anything. Would be nice if you do something the same UniID but you have in the GitLab, yeah. So I will be something like I don't know. Is that I'm not sure that the dot is allowed. Maybe skip the dot. So mine will be this. Plus add some kind of, if you plan to do several databases, then add something like DbDemo 01 or whatever else, like extension, some kind of. But there are no guarantees in this server. So if I'm running out of the disk or whatever, plan to upgrade, then I will just delete all the databases and restart the server. This is it. So no, don't keep your sensitive or important data there, please. Probably I will only do it in the next summer somewhere, but still, you are warned. The next major problem is this, especially on the next course, that I will put this demo up, I will upload into the Git, you will just copy it, and then you will not modify the connection string. And then everybody uses my database, what I have created, and drops it and migrates it and creates a different structure there. I will come to the next week lecture, start from the same place, run my application, nothing works, like mysterious database is there. So this is also kind of like the next issue. So please don't use my connection string value, use your own. And the third thing, now this has changed from the previous years. The server is not publicly accessible anymore. You can only see it from the inside school network, which means that you have to use VPN if you're home. Everybody has the VPN. We have the student or whatever, the uni VPN something, and also IT college one. So you need to connect with your uni ID and get the VPN access to the school network. Everybody knows how to do it? No? Let's see. Can I just find it just like that? EduVPN, for example, TalTech VPN.
Confluence select.
Mm-hmm. Here, got it here. Oh, there's even EduVPN client, some kind of special. Let's see what it does. Find your institute. Oh, like this way. Institute access. Yes. Approve. Hello, yes. Please add connection. Connected. Yes, give me notifications. Yes, I'm connected. Nice one. Let's see. What is my IP? Okay. Let's see, I got this.
There's no way to know because you're at the school network already.
Yeah, exactly. Let's see if I disconnect from here.
I can find a phone.
241.9. Let's reload it. Yep, it changed. Now it's 242. So it did work. And this gives you even more like nice things if you're from the inside the school. Then you're authenticated as coming from the school IP address. Some library services will work for you. Also, what you should get is this. No thanks. Is this O'Reilly? You have free access here, so you can read any of the O'Reilly books. So just sign in with your school email address and from the school network. At least last year, you have to come from the school IP address also. Good help. C#. O'Reilly is pretty famous, like IT publisher, so you can read anything from here. So you cannot download those, but you can read those. So you can program in C#. I think it doesn't allow you to download the PDFs, but I'm not so sure that it even allows it at all. But you can read it from the web interface.
Doesn't work for me.
Should work. Did you log in with the school email address?
Yes.
I don't know. Then I don't know. It should be free for all the students.
Maybe it has to be on the actual VPN and not just the school network. Because I'm just on the Wi-Fi.
Let's see. TalTech O'Reilly. Here, you can search for it. Now, you need to create your account in O'Reilly while you are in the while you are in the school network. And then when you have created your account while you are in the school network, then later on actually you don't even need the VPN, then it just works. And you probably got some kind of notification on the email that please click here to activate, blah, blah, blah. At least it should work. Did work for me. So, and you can then read all the books that O'Reilly has. But let's get back here. So now this parallel.itcollege.ee should be visible for you. I mean, the server is visible anyhow, but now you can actually connect to the database from here. And now we can use this connection string. From here. And now we are already almost happy with it. So let's try to use it and see what kind of errors do we get. Or the other way. Using our database equals new application DbContext. Reference and using. And let's try to access it. Person, or what it was, person count tb dot persons dot count. Did I spoke to you about the using clause somewhere?
In the recording.
In the recording?
Yeah.
Okay, so idea is that the concept behind it, why do we do it, or what's the idea here is this, that we don't take care of memory here. In the Java, in the JavaScript, in Python, everywhere, yeah? Nowadays we don't take care of memory manually. So there is some kind of automatic mechanism that tries to manage memory for us. It's called garbage collection. So when you don't use the memory anymore, somehow it's tracked and then it's get rid of when you don't use it. Now the question is what to do with all those weird things that garbage collection cannot take care of. For example, database connections, open files, stuff like that. That if you just get rid of the pointer to it, then the connection somehow hangs around in the system, God knows for how long. For those kind of things that garbage collection cannot handle automatically, you should do something like this, using, or not using, but open up the database and then finally db dot something like this, dispose. So the db.dispose tells that, hey, I'm done with this thing. Garbage collection cannot take care of that one automatically, so I have to do it manually. db.dispose basically it closes the connection and destroys all the memory that it's using. The using clause just makes it automatical. So when the using is over, then this thing is called automatically here at the end. So then it's gets disposed, database will be closed, memory is released, everything is happy. Now we have also what? Now we have new way how to do it. We don't need to write like using it, because maybe we will use many different things. We can actually do convert to the using declaration. Looks a little bit simpler, but basically what it means is this. Here where the method is over, db.dispose is called here, and xxx.dispose. So basically everything.dispose. So you can have many using clauses here, using this, using that. I'm using var blah blah blah. Declare many of those kind of new automatically not managed stuff, and then at the end of the method, when the method is over, then they are automatically disposed of. So it makes the code a little bit more readable. So let's try to run it and let's see what we get. We will get problems, but interesting ones, hopefully. Cannot open the database. Student Andres Kaver blah 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 DbDemo 001 requested by the login. Login failed. So it's not actually a problem with the login. The login went okay. It's a problem with the database. There is no such database. We tried to access it, but there isn't anything. So we actually need to create the database first. And now comes the a little bit more, not necessarily complicated part, but different part than it used to be. In the previous entity framework version, so the version 6, the Windows entity framework, all this thing will happen automatically. So you don't need to do anything special. You run your application, you just need to tell to the DbContext something, basically DbContext create database, and it will be automatically created. This makes your application about 2 to 3 megabytes bigger and uses a lot of memory initially. Because all this code that, hey, let's go here, let's grab those entities, the C# classes, let's read them through, let's construct some kind of SQL syntax out of those. Let's construct correct SQL syntax depending on the database engine, that MySQL is one way, SqlServer is the other way, Oracle or Postgres is the third way, what are the data types, etc., etc. So there's like lots of complicated analysis that needs to be done to actually convert this structure to the SQL sentences. Because there needs to be actual SQL sentences like create table, blah, 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 data type, this string, max length, blah, blah. So this is a pretty huge amount of code. And when we started with the Entity Framework Core, or when the Microsoft started with that one, I was there, so to speak. We had a lengthy discussion about it initially when this thing was designed, and then we decided that what the hell do we package it together with actual application code? Because this is needed only once. When you actually are done with your design, you can say that, hey, let's create now those sentences, and then they are basically there and it's ready. And you don't need to recreate them or modify them. So now this code is extracted or moved to the separate library. And we need to do it, call it out manually. That, hey, I'm ready with my database design. Let's create the description, what the database should look like. And this is called the migration. So initially we migrate from nothingness. We don't have anything yet, but we migrate to the first version of our database. Where is our documentation? So here, so basics, write your models. Every class needs primary key, yes. Are named, Mikk, oota, siin on viga sees mul, pane siia need ülakomad ümber. See klass on suure väikse märkide vahele kaob ära. Siin selle koha peal on tegelikult klass või siin. Aga seal on vaja need tagurpidi ülakomad ümber panna. So declare context class, we did that one. Inside context classes add the DbSets, yes, we did that one. So if you don't include all the POCOs in the DbSets, we did include everything, so no auto discovery from us. Don't rely on entity framework, automatic creation of properties relations, that one we need to check. And now we get here. Create a new migration. .NET EF migrations add initial create. And then where is our data access layer? And where is our startup project? From command line in solution folder. So let's try to run it. So let's grab a terminal. I am in the solution folder. Let's run it. And if the names match, mine's do, DAL and ConsoleApp, then it will run. Your project ConsoleApp doesn't reference. All right. Let's add that one to the ConsoleApp. All right, let's try it again. Done. And now here in the DAL project, I got this folder migrations. And inside the migrations, I have this initial create, actually two of those, initial create and initial create.designer, and application DbContext model snapshot. So maybe the only interesting thing is to look at this initial create class. So basically this describes all the steps that our model or our database needs to take to get from nothingness to the current situation. There might be just one migration, there might be several migrations. If you have done anything, for example, installed WordPress, then you know that WordPress update comes out, your data is not destroyed, your database is migrated from one older version to the newer version. New tables are added and columns are changed and whatever is done there. So basically the same thing here. Just now we have this first initial one, but you might add new one if you want to keep the existing data around. And here are two important methods, up and down, in this migration. So basically it means that migrate from the old version to the new one or go back and remove the migration. So the down seems to be yes, that everything just gets destroyed because there was nothing there initially. So to get back to the nothingness, everything has to be undone. And more interesting is this, what is happening on the up. And in the up, we can see how our tables are created, and we can check our database table names, table content, what fields will actually be there, what indexes are created, what will be the primary key. So how the structure will look like. And the first step to take from here is that try to at least somewhat validate that what is written here is what was there in your code. Especially all those foreign keys. If you see extra foreign keys, then something is wrong. So then something is wrong with your relationships. Either you have made mistake in the foreign key name that doesn't match actually the field name.id syntax, or something you have forgotten something, or anything else. So first you need to check that basically that the tables are all there, that you don't have any extra tables unexpectedly. And then inside the tables that you don't have any extra unexpected fields. especially foreign keys somehow coming out. So you can go over this and see that is everything there. Like, let's see. Logically, everything starts from the persons. Okay, persons, yeah, one person's table. Person ID is an integer, nullable false, some kind of SQL Server identity. Hopefully this is okay. First name, last name, yep, 2 strings. And the actual database type is nvarchar max. Initially it's okay, in the long run it's bad. Basically nvarchar max tells to the database that I can keep unlimited length of string here. If your database connection leaks somehow, somebody can get a direct access or via the web interface, they can store 4 gigabytes of text in one string and basically full up your database disk. Has happened to me. So it's better to limit the strings somewhat. But initially it's okay, let's keep it like this. Because it matches what you have in your entities. Because string length is not limited inside C#. Inside C# you can allocate as much memory as you want to for one string till you run out of 64 bits. So you can have what, terabytes probably, something. So they try to match it against the database also. Okay, so person has just 2 strings and this is it. Yep, matches what we have on the board. Person ID, first name, last name. Yep, true that. And then we have, where's the declaration? Course declarations. ID, yes. E-student, yes. Final grade was there. And then we have person ID and course ID. Okay, and I did find a mistake here. What's this? Why do I have here course declaration ID 1? What's this? Why?
It has a list of course declarations.
Yes. No, it's declarations. Okay, it will match with this name here. Yes, absolutely. What the hell I'm doing here? This cannot be list of course declarations. Course declaration will not have any kind of list inside it. Absolutely. What is it? So that's useful to actually check your migrations against what the hell is it? Where is this thing coming from? Course declaration only has the person, course, and I know what it is. This was list of grades here. Actually, that one is missing. Because grade points to the course declaration. Every person in our course will take on homework, will do all the homeworks, or hopefully, and gets a grade. So it has lists of grades from the homeworks he has done. Okay. So now when I did a mistake, now I have few different options what to do. First option is that I can take the migration back. The second option is that I can tell to the system that go to hell. Basically here its simplest step is to tell to the system that go to hell, because I haven't done anything in the database yet. I haven't run it. So I can just go edit, delete, get rid of the thing, and just run it again. And this is initially a pretty common thing to do. So when you're not yet done with your database design, it's easier just kill everything and start from scratch. Then you get the clean migration and can go over it and check that everything is okay. So let's see it again. Homeworks, course declarations. Yep, now it is as it should be. Course declaration, student, grade, and just the person ID and the course ID. Then we have bunch of constraints. Since those were described as one-to-many relationships. Then entity framework with the SQL Server. Nowadays also with the MariaDB or MySQL Server. Previously it was not supported, by the way, in the MySQL. We actually have something which is called foreign key integrity. So you are not allowed to insert a record where the foreign key actually doesn't point anywhere. So it isn't just a random like field. It actually verified by the database that it actually is or has an existing matching record in the other table. So this is what is described here. That this foreign key, course declarations, persons, person ID will match with the field name person ID, which will go against the persons table and the person ID column there in the persons table. And so SQL will take care of that. Plus we will get this referential action cascade. So when you delete the person, it will automatically delete everything else connected with that person. So all the declarations, all the grades, everything will go with the person. So it will do the cascade delete. Okay, grades seems to be okay. Yes, has the correct columns. Yep, everything seems to be okay. And now I can run this .NET EF database update. This tells the system that, hey, apply the migration. And not even migration, but apply the migrations. So if you have many and your database is old, it will apply all the migrations one by one, what is missing in the database, starting from the first missing one, and then goes to the end of the list. That's why also we got this timestamp here in the beginning of the migration, because those are ordered by those timestamps, by those file names. So if you mess up the file names here, if you put different numbers here, you can mix up the order of the migrations and then everything goes to somewhere. So don't change those names. And now I can run this and see what will happen. Will it actually work? I hope so. Doesn't work. And it has a problem. And the problem is this. There's different ways how to solve it. We did make a too complex database. On the little bit simpler database, this wouldn't be a problem. And depending on the database engine, this also might not be a problem. Problem is this. We now have this kind of relationship. And how do we cascade delete it? So we try to delete the person. Then here we have the course or the declaration. So that one goes there. This one goes to the grade. And something is here. So basically what it tells us is this, that it finds several paths to the one entity. And if I delete this, then I want to delete this, then I want to delete this, but then this will be hanging here and I cannot take care of it automatically. What to do? So one way what to do is we can try to manually help out the entity framework and configure it correctly, what shall be, how this kind of situation should be handled. Or we can do this out of the box, which I did put for you here on the slide somewhere. So let's jump ahead to the entity framework slideshow, and at the very end we have this. We can just copy this method. There's a slight mistake here, you can see already. Let's add it here. This one should be in the beginning. So basically what this will do to the system, I will put it into the chat. This will tell to the system that, hey, please go over all the relationships one by one and remove this cascade delete and replace it with delete behavior restrict, which means that do not allow automatic deletion if there are dependent childs hanging around. So it enforces that everything is always there. And basically this tends to be my default behavior. I want to delete everything manually. Or if I want to do cascade delete, then still I start with that one, remove everything. Don't let like unexpected surprises hit me that I will delete the person and the full database is cleared out of everything. And when I start to actually delete, then I either delete stuff manually one by one, at first the grades, then the declarations, then the persons. Or if I want to do the cascade, then I will add those in the specific places back manually, that okay, if I delete the person, then do this and do that. But don't leave it on like automatically. Remove the cascade delete globally. And now I can do it again. Delete the migrations, because this will change the migrations. Add it back again. And update the database again, so apply the migration. Applying migration, done. Now it went successfully. And actually now you should verify that everything matches. So you can match against, of course it's okay already to check against the migration file itself, but it's also useful sometimes to see what is going on with your database. And to access the database, SQL, we have few different options. One way is to access it from here. Here on the edge, I have this database, and you can actually connect from here. I do not recommend it. I mean, it will work, etc., but this is kind of like a crutch or like simple utility. This is not the full-blown database administrator tool. And for actually working with the SQL database or Microsoft SQL database, we have now this Azure Data Studio. Let me close everything. And I will delete the connection. So if you install that one, you will get this kind of like application. So this is based on the Visual Studio Code, actually. And now I can add the connection. So the server is parallel.itcollege.de. Authentication type is SQL login. Username was student, and password was student pass. Student.pass.1, I think. Connect. And now I can see all the databases. Who did this one? Gianono. It's not student underscore. I didn't read the instructions. But actually you can use any name. And now you can browse around inside each other databases if you want to. You can run queries and see what's going on and what data is there, and You can delete each other databases, and so please be nice. And if you hit any problems, then probably you need your own database server somewhere. So either then install Docker and run it inside the Docker instance, or use some kind of cloud service. I do not want to spend time that I will integrate UniID somehow here and or create the usernames manually or whatever. So just be nice with each other. Don't tread on each other's toes. And now you can see the tables, and we have one extra table here. So this __ EF migration history, and I can select top 1000 rows. And what you can see from here, that it shows you what kind of migration is applied to the database. So what version of database is it? So if you add additional migrations and apply those, you will get additional rows here. So the system knows what kind of version it is, and if you have like many migrations, then it knows what migrations to apply and starts to apply those in order and starts to migrate your database. And now we can actually check the data or check the structure or whatever you want to do, like columns. Is everything okay here? This is primary key, foreign key, data type is integer, not null. So you can go over all the data structure and see what is actually there in the database. Is everything okay? Or you can try to access the data, select top 1000. There's nothing there, but you can see the kind of like what the column names are. And now I can actually try to run it again, the console app. Hello world, person count 0. So it did connect to the database. Went okay. So what can I do now with this? I now have database. Now what? What is it good for? So let's see what it is good for. So the first thing we want to do is this, the CRUD. Everyone knows what the CRUD is? You should have it from your SQL course, yeah? Database course. Create, read, update, delete. The basic 4 operations you always want to do with any database. So the first thing, create. So var person equals new person. Person dot first name equals okay, now I have a person. I can always use an object initializer, whichever way you like. And now when I have a person, I want to add it to the database, so it's actually saved. So the first thing I need to do is this db.persons.add and the person. So one thing to notice or to keep in mind is this, that nothing happens here automatically. This doesn't add a person to the actual database. This will be just in memory. You need to do this db.save changes. Send data to DB engine.
Can we use transactions?
Then transactions are used automatically. Entity Framework does something which is called an atomic save. So if you do many changes at the same time, at once, and then they'll save changes, it tries to save. If something fails, everything is rolled back. So nothing happens in the database.
But how
So-
do you know if something has gone wrong?
If database engine gives you the exception, some kind of. This comes from the database engine.
Okay, so
If database engine gives you the exception, then Entity framework doesn't roll back anything. I mean, database engine itself rolls it back. So entity framework will just tell that start transaction, then commit data. If it fails, then you get error back, and database engine itself will roll everything back.
So if you just mess something up and like the query is correct, like syntactically, but it just messes something up with the data then.
Yeah, or like you use wrong foreign keys somewhere or something like that. Like you cannot do the connection because the data doesn't match or whatever else. So somebody has deleted something in meanwhile, because database, several persons are typically accessing the database at the same time. So your data might be totally out of the sync actually. You're reading the person, you get the person ID, you start to add it to the course, it's already there, somebody has already done it, or somebody deletes the person meanwhile, or whatever can happen. So it's always checked. We will speak about it next semester at length, like there are different techniques and what to do and what kind of situations to avoid, etc., but basically it's atomic. So if the data cannot be saved, then it will not be saved and everything is rolled back. So initially, this is kind of like the first step. Now we can try to read it back, what is there in the database. And we can even use this line again. Ask for the person count. We can even ask it here before we save it to the database. So theoretically, this might be answered from the memory already. So what will happen, because this person is not yet actually in the database. So how many persons will be there in the database in this row here? Is it 0 on the initial run, or is it 1? And then we can let's write out all the persons. So for each, db.persons. So we have this db person now. And let's just console.writeLine. Let's write the db person out. Of course, this will not write out anything useful. So let's go to the persons and let's add a toString here. Why is it red? Possible null reference, redundant method over to whatever. God help. Nee. Return. What do we want to return? I want to return everything from here. So it's person ID. Then it is the first name, last name, and maybe also the course declaration count. So the first name, the last name, declarations, and this might be a count to string null. Okay, some nice toString. So let's run it and see what we get. And especially interesting is both runs, what we will get on the first run and what we will get on the second run. And even more, I want to write out the person also here. Let's write it out here. Before we add it to the database. Then when we add it to the database. And then let's write it also here. After the save changes, what will happen? For example, interesting question is, what is the value of the primary key? What is it initially? Should be 0, because it's a default integer. When will it actually get the value from the database? So when will actual database value will be there? So is it only after that we read it back, or is it already automatically after the save changes? So there's like a bunch of interesting questions here. And maybe to see it a little bit better, let's just write it out what we are doing also here. So this is before DbSet add, yeah? So this is after DbSet add. Okay. But before save changes. And this one is after save changes. Okay. List all. All right, let's run it. Okay. Person count 0 initially. So before DbSet add, it's a 0 is the primary key, undiscover declarations null. After DbSet set add, but before save changes, still the same. Person count is 0, by the way. That's interesting. Because we add it to the persons, but persons count is still 0 here. Interesting. Why? We need to check. Where does it take the 0 from? Is it from the in-memory, or is it from does it actually execute a query against the database? So what is it? Okay, after save changes. So this is more interesting. We now have the primary key value. The 0 was changed to 1. So we didn't ask specifically to load the record back, but the save changes automatically updated primary keys. So we don't need to go back to the database and load the person somehow from the database. We already have the primary key value for it. Nice. And list all tries to list them all. Okay, let's run it again. Person count 1. This is 0, this is 0. Person count is still 1. After save changes, new ID is 2. Yes, because it's the second time I had the same record. Person count is now 2. Yep, that seems to go against the database and ask from the database what is going on. And list all gives me the 2 records. How much time do we have? Like half an hour, yeah? 15 minutes officially and half an hour till the next lecture starts. Okay, so we can actually already fix it here a little bit, like with the comment. So this is the read. So now we want to do the update. What do we want to update? Interesting. No, let's do the other one, more specific read. Person from DB equals db.persons.where, let's say. We can write something like this. So we are back to the link, to the language integrated native queries. And we can say that, hey, go over the persons, execute this predicate on every row. If the predicate returns true, So all the rows where the person ID is equal 1, there's just one of those, should be, or maybe 0. And then grab the first one.
I guess you can only use the first two.
And we can just replace it with this first. And now not the problem, but the issue here is, or how it works is that the first actually tries to grab the first record from the results. If there are none, then this will crash. That will be an exception. If you want to get the first record or null, then we have this first or default. So now this person from DB might be null. So if it's not a null, now we can just update it. First name equals, and I can do something like this. For example, GUID, new GUID to string. And let's just add it to the name, and maybe a space also. This will just give me the random new GUID. So string 128-bit string number converted into hexadecimal. And I can do the same with the last name. And I just need to call db.save changes again. And I can just go up and do the new read. So list everything what is there in the database. Or maybe person ID second will be better because I have already run it. I know if you run it first time it will crash because there's no second, so let's keep it to the first. So let's run it. Yep, I got this now. Andres plus guide and cover plus whatever is the random guide. And when I run it again, it will just get longer and longer because new guide is added every time. And just in case, you can go here. Let's close all. Persons, select top 1000. Yep. Seems to be in the database. And you can do something like delete from persons where first name is not equal to the owners. Can I do something like this? Run. One row affected. Let's run the query again. Yep, got rid of that one. So if you don't select any rows here or any text lines and you click run, everything is run. If you select something and click run, then only just the selected portion is executed. You have to learn this language. There is no way around it. Sooner or later, you have to learn how to write SQL sentences, and pretty complex ones. There's just no way around it. The entity framework or any other ORM will do pretty complex stuff for you. But the first thing what will happen if you try to do complex stuff with entity framework is that you will get unexpected results. And then you don't understand why, and then you need to read the SQL that was generated, and then it's really, really hard to understand what the hell is going on if you don't understand SQL. And then finally somewhere you will discover that doesn't matter which ORM it is it entity framework or some other, you just cannot execute or get the query you want to. It's just not possible. The ORM doesn't figure out the way how to do the complex thing you want to do, and then you need to write the query yourself manually. You can do it totally well inside the entity framework. If you want to do some complex updates or complex whatever queries, then you have to write those manually, and then you have to know how to write SQL sentences. So basically, then I'm back here. I first write the query here, step by step, execute it, see that, okay, now I finally get the correct result, and then I will copy it over to the C# code and add it there. Of course, it's kind of like a bad approach, somewhat, because this is, once again, magic string, basically. So if you change your database structure, then nobody will update your SQL syntax, or whatever you have there in the SQL, then this can fail, but sometimes it's the only way, so there's no way around it. So this was the update. And now we only have the delete. So we can do the same thing. Grab the person from the database. Actually, this will already fail because now I don't have the primary key 1 anymore here. So I need to update that one here. So let's update the second one. And I can do even this here. So just give me the first one from the database without any like filters. Just give me the first whatever. And now I can do this db.persons. What is delete? Or remove. Okay, it might be null. Hopefully not. So this is the warning. What can I say here? I can say here, I don't care. It's not null. I know better. And once again, nothing will happen. You need to call save changes, otherwise it's only in memory. So in theory now the person ID with the person with an ID 2 should be deleted. So let's run it. Yep, ID 2 now got those names added, or those quids added to the name. We don't list it again, but let's check from here. If I run this query again, yep, the 2 is gone. It's not there anymore. So this was your crash course, kind of, into the entity framework. So design your model, your classes, what your system is about. Then make your DbContext, that one here. List all the DbSets. Then configure your database. So what's your connection string and what's your database engine type. Then maybe if you need to get rid of cascade delete, which is kind of my default approach, that everything is, that I don't use the cascade delete. If this is done, then create a migration, then apply a migration so that the database gets created, and then start to use it. And we have all those kind of initially really simple create, read, update, and delete methods. And important notice here is this, that nothing happens in the database before you actually call the save changes. So till you call the save changes, everything happens just in memory. Nothing is synced back to the database. So this is it for today. Shall I give you homework? No? No? Okay, then it will come on the next Friday, because we go there into a little bit more depth in details how the entity framework works, and then basically you can see your next homework. In addition to that you save your state to the JSON, you also need to save everything to the database. So basically you have your homework. It's not just defined yet, but you know what to do. So you have like 2 save options, like save and read from the JSON, or save and read and delete and list and whatever else from the database.
For the next
No, it's I will give the homework out next Friday. But I already described you what it will be. So if you want to, you can already start. So, see you next time then. Küsi.
Aga miks, nagu ma ei saanud aru, miks kui me proovisin nagu listist need persons nagu proovida vaadata, miks oli null?
Null, mis asi oli?
No nagu proovisin nagu read need persons listist, programmi listist ja siis count oli null.
Count peabki ju null olema, sest me ei ole midagi ju, see null, sa mõtled see siin või? See on declarations.
Nagu lihtsalt null, nagu nii on.
Sa mõtled, kui me algus, kui see esimest korda runnid, sellepärast, et see count läheb andmebaasid küsima. Tema läheb küsib.
Aga meil on selline asi, et me nagu küsime DbSet ja siin, aga miks ta nagu läheb? Ma mõtlesin, et see on nagu meie objekt. Aga
see läheb, tema läheb andmebaasi ikkagi küsima.
Aga kui me paneme DbSet, siis ta paneb objekti sisse. Ja siis kui kasutame see save changes, siis juba paneb andmebaasi.
Jah, siis paneb andmebaasi. Ja siis, kui sa küsid uuesti, mis count on, siis on count 1.
Kes on natukene imelik?
No, see töötab niimoodi, jah. Et teistpidi tekib jah, nagu sa oled järgmised igast huvitavad küsimusi. No mõlemad pidi on huvitav, et kui sa teed nagu add ja midagi ära ei salvesta, et mis siis see count nüüd nagu olema peaks. Ja siin veel tekib veel igast nagu huvitavaid küsimusi, mis on tegelikult nagu pull. Ma kommenteerin praegu selle siit välja. Et ma ei update'i siin midagi. Nii, siis läheks siia. Teeme siin selle, laseme kõik tühjaks, hakkame tühja andmebaasiga peale. Nii, andmebaas on tühi, kõik on, ma võin siit run, on tühi. Võtame nüüd seda siin, me teeme uue personi, addime selle. Nii, persons count on 0. Nii on ju DbSet changes, me küsime uuesti person count'i. Ja kui ma nüüd teen näituseks veel kord niimoodi, võtame selle osa siit uuesti. Nii on ju. See on nüüd minu person 2, Nii on ju, ja küsime nüüd veel kord. Nüüd on veel nagu pullime, et mis nüüd saab? Nii on ju. Person count on 0 on ju. Nii, nüüd ma teen save changes ära. Nüüd on person count on 1 on ju.
Ta vaatab nagu andmebaasi.
Jaa, andmebaasi. Nüüd me paneme siia veel ühe juurde on ju. Aga person count on nüüd ikkagi 1 on ju. Läheb uuesti andmebaasi on ju, sest me panime veel juurde on ju.
Ja siis kui me nagu save'ime praegu.
Ja kui sa nüüd save'id, ja siis on juba 2 on ju.
Siis lihtsalt on vaja pähe.
See on vaja meelde, ja see meelest töötab kõikide ormidega niimoodi. Kõikide ormidega, mul on Javas täpselt sama asja. See ei ole ainult entity framework'is, et see on nüüd küsimus nagu huvitav, mida see on igat moodi sellest mõelda, et mis see nagu õige siis nagu oleks. Kas see, et me liidame nagu mälu ja andmebaasi kokku või mida me siis nagu teeme või on nagu, kas see nii-öelda single source of truth, et kas see nagu andmebaasis, mis siin nagu nüüd juhtuma peaks. Ja see on üldse, see käib kõikide asjade kohta. Et kui sa nüüd muudad näiteks mingit entitit, ma muudan selle eesnime perekonnanime ära, aga ma ei salvesta tagasi seda andmebaasile, ma ei tee veel save changes. Kui ma nüüd teen list persons ja hakkan neid eesnimesi perekonnanimesi välja kirjutama, millised nimed ma nüüd siis välja kirjutan? Kas ma kirjutan välja need, mis on andmebaasis? Või kui ma lähen küsin andmebaasist, et anna mulle kogu see list, siis mis ma teen selle entitiga, mis mul on mälus nagu muudetud parasjagu? Seal tekivad igasugused nagu niisugused huvitavad küsimused, mida on aeg-ajalt vaja nagu proovida, et mis siis täpselt nagu juhtub. Et mis see nagu, mismoodi see engine nagu käitub. Ja
siis nagu me peame ise nagu välja mõtlema, kuidas me nagu...
Sa pead ise nagu välja mõtlema, sageli tuleb ise nagu proovida, et mis kuramuse värk nüüd sellega siin nüüd nagu täpselt nagu on, et mida nüüd siis nagu parasjagu nagu tehakse. Et seal on nii-öelda doubt everything on ju, test everything. Do not believe anything nii-öelda. Et nagu seal võib igasugust üllatust. See on nagu, mis on nii-öelda tänapäeva inimestel palju puudu, kui sa oled meie kaunist ajakirjandust, kes usub vaktsineerimist ja kes ei usu, on ju. I did my own research, on ju. Persekki see nii-öelda your own research keegi nagu teeb, on ju. You just think that it works like that and then you somehow suddenly believe it and you don't try it, you don't test it and then you get like unexpected results and then you're like, what, on ju. So you really have to think about it a little bit. So the same way with those nullables. So don't assign like default exclamation point just like that. Think a little bit about it. Why is the exclamation point or default exclamation point? Why is it okay or why isn't it okay? What actually will happen there? So have what it is, scientific approach.
Okay.
Yeah, palun.
Really quick question for web security. Are you gonna send us your range course?
Yes. Yes, I got it working this morning.
Okay.
So I will send out the list.
You will check it every.
Yeah, I will send it. You will get email about it.
Okay. All right, thanks.
Küsin, tõus. Ma pean WC-sse ka vahepeal minema. Piss püksi mida.
Ma ei saa seda meetkasvamist. Ma leisin, kus sa asud.
Üks kinni panna.
Aga mis sa sellega seal otsustad?
Pea vaatama, mis maailmas toimub. Kiirelt tuleb värskematest mevedest ülevaade saada.